Morning, students. Welcome to another session on advanced predictive modeling. Today, we'll be looking at learning outcome 1. Tomorrow, we'll be looking at learning outcome 2. And then the next week, we'll be looking at learning outcome 3. And then lastly, assignment discussion. So what is learning outcome 1? Learning outcome 1 is develop models using binary logistics regression and assess their performance. So what is the unit aim? This unit will introduce you to some of the most widely used predictive modeling techniques and their core principles. Throughout this unit, you will form a solid foundation of predictive analytics, which refers to tools and techniques for building statistical or machine learning models to make prediction based on data. You will also learn to carry out exploratory data analysis to gain insights and prepare data for predictive modeling. So what are the indicative contents? We have 4 indicative contents for this learning outcome 1, which is latent variable model, probabilistic model, using programming or codes for models, probability distribution, linear predictor, link function. And then lastly, ordered response and unordered response. So those are the 4 indicative contents that we'll be looking at today. Yeah. Key terminology, we'll be looking at what regression problem is. Like basically, it's usually about like us knowing what regression is. So regression problems are prevalent in machine learning, and regression analysis is the most often used techniques for solving them. It is based on data modeling and entails determining the best fit line that passes through all data points with the shortest distance possible between the line and each data point. While there are other techniques for regression analysis, linear and logistic regression are the most widely used. Ultimately, the type of regression analysis model we adopt will be determined by the nature of the data. So at the end of the day, the type of regression model that we use will be determined by the nature of the data. That means that how the data is or how the data looks. So yeah, first of all, we have to understand the purpose of regression model. So what is the purpose? Why do we need it? What is the use? And also regression analysis is used for one of 2 purposes: predicting the value of the dependent variable when information about the independent variable is known. So basically, we use it to predict the value of dependent variable when the information about that independent variable is known. That means that we literally know the information about it, or predicting the effect of an independent variable on the dependent variable. What is regression analysis? So we have an image here. So predictive modeling techniques such as regression analysis may be used to determine the relationship between a dataset dependent or goal and independent variable. So we determine the relationship between a dataset and the independent variable. Also, it is widely used when the dependent and independent variables are linked in a linear or non-linear fashion, and the target variable has a set of continuous values. Regression analysis, for example, is the best way to determine the relationship between sales and advertising expenditures for a corporation. So a good example of how we use regression analysis is examining the relationship between sales, which is sales, and advertising expenditure for a corporation. So also, what are the types of regression analysis? There are numerous regression analysis approaches available for making predictions. Additionally, the choice of technique is determined by various parameters, including the number of independent variables, the form of regression line, and the type of dependent variable. So right here, let us go into more detail, because it is possible that you need it for your assignments. So yeah, the question. we have this. Excuse me. We have this article that provides more detail and insights into the type of regression models. Yeah, give me a sec. I think you have to log in when you're trying to access this website. So you can do that at your own convenient time. And so yeah. You can use the two links to know detail about what regression analysis is. So the first example, like you can see here, is linear regression. I'm not sure if I can find a way to get rid of this model. Even if I do, we can still scroll down. Yeah, so anyways, yeah, moving on. With linear regression, the most extensively used modeling technique is linear regression, which assumes a linear connection between a dependent variable y and an independent variable x. It employs a regression line, also known as best fit line. So we have this line, which is linear regression line, and then in between that line, we have loads of data. So it assumes a linear connection between a dependent variable x and an independent variable. A dependent variable y and an independent variable x. So obviously, we know what the x and y axis on this chart is. So that's actually what linear regression is. And yeah, for more details, you can obviously find a way to log in into this website and read more about it, or you can, yeah, there are loads of example and those of more explanation on what linear regression is. So just pop into Google and try to make a research on it. Give me a sec. Give me a sec. Yeah. So let's continue. So linear regression, the linear connection is defined as y, which is equal to c plus m times x plus e, where c denotes the intercept and m denotes the slope of the line, and e is the error term. The linear regression model can be simple with only one dependent and one independent variable, or complex with numerous dependent and independent variables, with one dependent variable and more than one independent variable. Yeah, we have a clear definition on the IBM website of what linear regression is and why we use it, why it is important, and then, yeah, examples of linear regression. Yeah, like we said in the previous slide, evaluating trends and sales. Yeah, so you can use this website as a starting point when you're trying to work on your assignments. Yeah, moving on. We have logistic regression. When the dependent variable is discrete, the logistic regression technique is applicable. Also, yeah, in addition to that, we also have what logistic regression is. We should be able to also find it in the same IBM website. And an example is, yeah, assess credit risk, increase profits in banking. Obviously, you can open this as PDF to see more, to see it into detail about how this company use logistic regression. And then, yeah. So this also provides how using binary logistic regression to assess credit risk. So yeah, that's another good example of that. So moving on. In other words, this technique is used to compute the probability of mutually exclusive occurrence, such as pass or fail, true or false, 0 or 1, and so forth. The target variable can take on only one of two values, and the sigmoid curve represents its connection to the independent variable and probability as a value between 0 and 1. Just give me a sec. Yeah, give me a sec. Yeah, moving on. Polynomial regression. So the other one is polynomial regression. The technique of polynomial regression analysis is used to represent a nonlinear relationship between dependent and independent variables. It is a variant of the multiple linear regression model, except that the best fit line is curved rather than straight. So like in linear regression, we have a straight line, and then the polynomial, it is curved. So always like we have the curved line, and then we have like data points in between. And then we have ridge regression. When data exhibits multicollinearity, that is the ridge regression. That is the ridge regression technique is applied when the independent variables are highly correlated. So yeah, we have an image that shows that. Also, while least squares estimates are unbiased in multicollinearity, their variance are significant enough to cause the observed value to diverge from the actual value. Ridge regression reduces standard errors by biasing the regression estimates. The lambda variable in the ridge regression equation resolve the multicollinearity problem. Give me a sec. Again. Why is it going back for some reason? Yeah. So, and then we have lasso regression. As with ridge regression, the lasso, which means least absolute shrinkage and selection operator, techniques penalize the absolute magnitude of the regression coefficient. Additionally, the lasso regression techniques employs variable selection, which leads to the shrinkage of coefficient values to absolute 0. So we have the comparison between lasso and then the ridge. So this is a ridge with collinearity, and then this is lasso with collinearity, and then we have the log lambda. We looked at what like lambda is. So lambda variable in the ridge regression equation resolved multicollinearity problem. So yeah, so that is literally what it is. And then CMOS, collinear, temp, stock price, and everything. So we can see the difference between lasso and ridge regression using this chart. Moving on, we have quantile regression. The quantile regression approach is a subset of the linear regression technique. It is employed when the linear regression requirements are not met or when the data contains outliers. In statistics, econometrics quantile regression is used. And then we have Bayesian linear regression. So let us quickly look at what this quantile regression means. Like more detail about it. All this is literally for your assignments and all, so you can use all these websites as reference for your assignments. We have a good example of quantile regression. Yeah, let's just read through it. Example: what is the relationship between total household income and the proportion of income that is spent on food? Engel's law is an observation in economics stating that as income increases, the proportion of income spent on food falls, even if absolute expenditure on food rises. Applying quantile regression to this data, you can determine which food expense can cover 90% of the family. For 100 families with a given income, we're not interested in the main food expense. So that is a good example of quantile regression. Yeah. Moving on, we're supposed to look at Bayesian linear regression. What is Bayesian linear regression? This is a form of regression analysis technique used in machine learning that use the Bayes theorem to calculate the regression coefficient values. Rather than determining the least squares, this technique determines the feature posterior distribution. And lastly, as a result, the approach outperforms ordinary linear regression in terms of stability. So this outperforms just like the normal one, the normal linear regression that we'll be looking at all morning. So yeah, just for your reference, you can look at what Bayes. And then I love the IBM website. Hopefully, oh no, you can't see the IBM website. So let us look at this. And then this, one of my favorite websites is this. Yeah. So this literally explains and give you a good example on how to implement Bayesian regression and all. And then it also has its theorem, yeah, that you can use. Also, yeah, you can use this website too as a starting place. Yeah. So we have a chart showing the Bayesian linear, the difference between the true regression line and the Bayesian linear regression, and then the outliers and the data on the chart too. Principal component regression, multicollinear regression data is often evaluated using the principal component regression approach. The significant component regression approach, like ridge regression, reduces standard errors by biasing the regression estimate. Principal component analysis, PCA, is used first to modify the training data, and then the resulting transformed samples are used to train the regressors. What is partial least squares regression? The partial least square regression technique is a fast and efficient covariance-based regression analysis technique. It is advantageous for regression problems with many independent variables with a high probability of multicollinearity between the variables. The method decreases the number of variables to manageable number of predictors, then it's usually utilized in a regression. So that's what partial least square regression is. And then we have elastic net regression. So we have the lasso coefficient part, elastic net coefficient part, and then S lasso coefficient part and SRF coefficient part. So this is literally the difference between all this regression example using that chart there. And yeah, it's just an explanation of what elastic net regression is. This combines ridge and lasso regression techniques. So we can see it here. We can see it here. This is lasso, and then this is SRF is ridge. So we combine both together. Yeah, so yeah, particularly combined ridge and lasso regression techniques that are particularly useful when dealing with strongly correlated data. It regularizes regression models by utilizing the penalties associated with the ridge and lasso regression methods. So this brings a conclusion to what we've been looking at so far. And then the summary: machine learning employs a variety of other regression models, such as ecological regression, stepwise regression, jackknife regression, and robust regression. In addition to the ones we discussed previously, for each of these various regression techniques, know how much precision may be gained from the provided data. In general, regression analysis provides two significant advantages. These are the two advantages that it provides, and this includes: it denotes the relationship between two variables, one dependent and one independent. It demonstrates the magnitude of an independent variable's effect on a dependent variable. That's the summary. Just to like recap and go back to what we looked at today. We looked at a new topic, advanced predictive modeling, and then this is the unit M, and then the indicative content, and then the key terminology, and then we look at what we look at the purpose of regression model. We look at linear regression, among other things, linear regression, type of regression analysis. Yeah, linear regression, logistic regression, and so on. But right now, just for like a clear explanation, we can literally watch this video for clear explanation of what we just discussed.
Hello, and welcome back to Data Science Wednesday. My name is Tessa Jones, and I'm a data scientist with Decisive Data. And today we're going to talk about predictive analytics and what it can do for you. Predictive analytics fits into the spectrum of analytics that we've talked about before. Starting with descriptive, which is the most basic of the analytics, is basically just cleaning, relating, summarizing, and visualizing your data, really getting to the questions about what's happening in my business. And then there's diagnostic, which is really getting down to why things are happening, what's causing my revenue to decline or to increase, how are things related, things like that. So if you've got a good base in both of these, then we're ready to move into predictive analytics, which is going to dive into what's going to happen in the future, which is super powerful. If you're a business person and you want to be able to make good business questions, if you have at least an idea of what might happen in the future, your answers are already going to be a little bit better. So let's dive in. So let's go with an example, because that just makes it easier to kind of flow through what's actually happening here. So let's pretend that we are grocery store owners. And if we're already talking about predictive analytics, you should have a pretty good grasp on descriptive and predictive and diagnostic analytics. So you probably already have a decent dashboard that really tells you what's happening in your business right now. So something like this, where you have something here that tells you revenue by different departments, like foods, meats, or foods and pastry, or how your sales changes by product or over time, things like that. So you have an idea of what's happening in your business, but now you really want to know what's going to happen in my business. So one really common question is, how many of a given product am I going to sell for every store? Because this can really give you answer questions around how you're going to support supply chain processes or how you're going to manage the profits that you're going to have, things like that. So the first thing we need to do is talk about what happened in the past. We really can't do anything or predict very easily unless we know or at least have an idea of what's happened in the past. So here we have 3 lines in black that represent basically historical data. Each line here is 1 year worth of sales for a given product. And then the green line here is the current year, and here's today. And if we build a predictive model, it's going to tell us what's going to happen for the rest of the year. So if this is all set up and we build a model, basically we mix this information with all the data that's really clean and well organized. We mash it together with a bunch of mathematics and coding, and basically we pop out some results. And it shows up in a visual like this, where you have, these are the sales that we have had, and these are the sales that we think we're going to have. So a business person can look at this chart and say, wow, we need to put a lot more products to this store because I see sales are going to increase. Or our profit margins are going to be way higher than we thought, so we can start a new program. Things like that. You can really start to get innovative with your business decisions. So let's pretend we've built this model and it's been running for a year. And now we want to know, how well is this model actually performing? So down here we have a chart that shows in black what we actually sold, and then in green what we thought we were going to sell. And we see that there's a couple of pretty big misses. Right here, we sold way more than we thought we would, which leaves risk to, missing out on inventory. Or here, we predicted we would sell way more than we did. So both of these are kind of misses. And so we need to go back and look at the data and understand what assumptions we applied that were maybe a little bit wrong or applied incorrectly, or look at the data, maybe we weren't accounting for something. And we kind of reorganize that and incorporate it into the model. And then we redeploy it And then we have a better model. This cycle can, happen a couple times, or it can happen many times. It really depends on the data. It really depends on the objective. It depends on a lot of different things. But we do try to minimize the number of times that we're having to iterate through this before we can have a really sound predictive model. So that's predictive analytics in a nutshell. Basically, once you have a solid foundation of descriptive and diagnostic analytics, we can really start pushing forward with predictive analytics. And then next week, we're going to start talking about prescriptive analytics, which really gets to the questions of, okay, now that we know what's happening in the future, what do we do about it? I'm Tessa Jones, and that's a reindeer.
Yeah, let's watch another video on regression analysis.
Analysis. Regression analysis is a technique that helps us to analyze relationships between variables to better understand the world around us. Variables are items of data that describe an attribute or characteristic of an object or participant. They can be categorical, placing objects or participants into discrete groups, or continuous, placing an object or participant somewhere on a scale according to a specific attribute. In data analysis, variables can be assigned as predictors, also known as independent variables, or outcomes, also called dependent variables. There are many applications for regression analysis. Within longitudinal studies, we can examine how early life circumstances or characteristics relate to outcomes in adulthood, middle age, or later life. For example, we may want to see whether there is a clear relationship between people's academic performance at school and their life satisfaction in middle age. Using a scatter diagram, we can plot the life satisfaction score of individuals in our sample against their average academic achievement. We can see that there is a pattern. But can we say how much more satisfied with life people can expect to be if they averaged 1 grade point higher at school? How about if they averaged half a grade point lower? We can summarize the data on the graph by drawing a line roughly through the middle of all the data points. This is the regression line, and we can use it to estimate or model the relationship between our independent and dependent variables. From this model, we can predict that someone who had a grade point average of 2.5 would approximate a life satisfaction score of 7.6 out of 10. This is around 0.8 lower on average than someone with a GPA of 3.5, whose life satisfaction score would be around 8.4. It is important to remember that the line is just an estimation and will not predict the outcome perfectly. One of the advantages of regression analysis is that this simple model can be extended to include more and more independent variables. This is important as it allows us to adjust for variables such as confounders. Confounding variables are related to both the independent and the dependent variable, but are not an intermediate factor on the pathway between them. For example, we might suspect that sex confounds the relationship between academic performance at school and life satisfaction in middle age, because girls achieve better academic results than boys, and women also report higher life satisfaction than men. With regression analysis, we can simply add a variable for sex to our model. After controlling for sex, the estimated association between academic performance and life satisfaction in middle age is weaker. You can continue adding more and more variables to regression models. Regression models are therefore a powerful statistical method for understanding the relationship between variables. To learn more about regression and how it can be performed in different software packages, check out our guidance and suggestions for further reading on the Closer website and learning.
Yeah, so this brings an end to our session for today. And yeah, I'll see you tomorrow for learning outcome 2. Thank you for attending. the class, and yeah, see you tomorrow.